So now we have a situation where this guy's trying to pull a box. He's applying a force of 120 at 30 degrees. So let's just draw some things. We've got the normal force. We've got the tension, which is the pulling force. We've got the weight. And of course, we have the friction force opposing the motion. One thing I want to do, though, is I want to split this tension force, again like we did before, into its x and y components. So we have a tension here, a tension component here, that's Tx equal to T cosine of theta. And in this case, theta is going to be 30 degrees. And we have the vertical component of tension, Ty equal to T times the sine of theta. So we're going to use the vertical components of the forces to determine the normal force. So we've got T times the sine of 30 plus the normal force that's unknown minus the weight. And again, let's just get that weight as 800 newtons equal to 0. So that's going to be 120 times the sine of 30, which is 0.5, plus the normal force, minus 800 equals 0. So ultimately, we're going to get a normal force equal to 740 newtons. All right, now we want to figure out if the box moves. To do that, what we need to do is actually calculate the force of the maximum possible static friction, and compare it to the horizontal component of the pulling force. So here, the first thing we need to do is let's get the x component. So Tx is going to be T times the cosine of 60. So that's going to give us 120 times about 0.87, which is going to be about 104 newtons, is what we'll say. Now, here's what we want to do. We want to actually now calculate the maximum friction, the maximum possible static friction. So to do that, we're going to take here mu, which is 0.3 for static, times the normal force, which is 740. And when we calculate that, we're going to end up getting 222 newtons. So the answer is no. And let's just go in a little bit detail more as to why. So the equation, and we're going to kind of solve through while we're at it. So the x component of the tension minus the friction force, okay? If the box doesn't move, that should balance. So here's what we're saying. The maximum friction force possible is, again, 222 newtons right here. But we're only pulling horizontally with a force of 104. So this friction can absolutely go toe-to-toe with the x component of the pulling force. So no, it won't move. So here we're going to have 104 newtons minus the actual friction that's happening, and those balance. So the force of friction in this case is going to be 104 newtons. Okay. Now, we have a 360 Newton normal force. Let's go ahead and get the new normal force. So, I can actually borrow the equation from up here, but it's going to be solved with different numbers. So let's go ahead and do that right now. So we're going to have here 360 times the sine of 30 plus Fn minus 800 equals 0. That's going to give us a normal force equal to 440 newtons. Now, let's calculate if the box is going to move. So the maximum static friction is going to be mu times the normal force. That's mu static times the normal force, which is going to be 0.3 times 440. Which works out to 132 newtons. Now, let's compare that to the x component of the pulling force. So Tx is going to be 360 times the cosine of 30, which is 360 times about 0.87 when you put it in the calculator. That's going to give us about 313 newtons. So check it out. This is the maximum possible friction. It can't keep up with a 313 newton force. So the answer is yes. Finally, let's get the acceleration. So the applied force in the horizontal direction, I could write this way. The x component of the tension minus, now since we know it's moving, it's going to be the kinetic friction equals the mass of the box times A. In this case, that's going to be 313. And now for the kinetic friction, let's go ahead and calculate that here. That's going to be 0.1, because that's mu k, times the normal force, which is 740. And that's 74 newtons. So 313 minus 74 equals our mass, which is 80 times A. And when we solve, that's going to give us an acceleration of about 2.99 meters per second squared. So 313 minus 74. All right. Yep. 2.99 meters per second squared. All right. So that is problem number